Just
Oh, that's
give me the go.
And the rest of us should mute.
Ready to go?
Yep.
Okay. Welcome, everyone.
Lee, I think we might want to just wait.
Okay. We'll wait a moment.
All right, maybe we get started in about a minute or two.
That sounds fine. Just give me the go ahead when you're ready for me to go.
All right, people are still hopping on. So welcome, and we're going to get started really soon.
Yeah, we're up to 76 and it seems to be stabilizing.
All righty, Lee, why don't you get started?
Hello, everyone. Welcome on behalf of the International Network for Environmental Compliance and Enforcement and the Environmental Law Institute that serves as Secretariat for INES. My name is Lee Paddock. I'm a visiting scholar at ELI and serve as Managing Director for INES. Today's program will focus on citizen science, concepts and approaches for enforcement. This is the first of a 6-part series on the role or potential role of citizen science in environmental enforcement. Our second program will focus on water issues and then air issues for the third program. Our fourth program will deal with natural resources and indigenous peoples. Our fifth program will look specifically at how citizen science might be used by government agencies or is used by government agencies, and both the opportunities and barriers associated with that. And then we'll conclude towards the end of the year in December with a panel of that will focus on future directions for citizen science in the context of environmental compliance and enforcement. These programs will be spaced roughly 2 weeks apart, and information about each of these programs is available on the INES website. First, a brief word about INES, who, for those of you who may not be familiar with the organization, INES has been in existence about 25 years, an organization originally founded by the U.S. Environmental Protection Agency and the Dutch Ministry of Environment. Today we have regional networks in Africa, in Asia, and in the Americas, but INES members organizations around the world. So we're very pleased to have the opportunity to provide information to folks who work in environmental enforcement and compliance work everywhere around the world. We titled this as a program on citizen science. The terminology is different in different places around the role of citizens in issues like advanced monitoring. In some places it's called community science. We use citizen science because it is currently the most common term used for gathering information by citizens. And citizens can include individuals, NGOs, often universities are involved, related to environmental conditions. After the presentations today, there'll be an opportunity for question and answers by the panelists. As you think of questions, please use the either the chat box or question and answer buttons on Zoom to submit those questions to us, and we will then answer questions after all of the presentation. We do have a fairly large audience today, so we hope to get to as many questions as possible, but we may not be able to get to all of those questions. There will be a follow-up report which may be able to address some of the questions we weren't able to get to. And of course, this is the first of a 6-part series, so we may be able to get to some of your questions in subsequent programs. I'm now going to turn to the program itself, which will be moderated by George Wyeth. George is a visiting scholar at ELI, focusing on citizen science. He co-chairs the Citizen Science Association, which is an international association. He co-chairs their legal committee. He's a former senior staffer at EPA's Office of Policy, and he co-authored with me and Allison Parker and a couple of other law faculty members an article on citizen science in the March 2019 edition of Environmental Law Reporter News and Analysis, which is an ELI publication. So George has really extensive background in the citizen science area, and I'm pleased now to turn the program over to George, your moderator for today's presentations.
You know, after 1,000 Zoom calls, you think I would know to unmute. Thank you, Lee, and welcome everyone. I've got the names of today's speakers up, but I'll skip through that quickly. We'll introduce them as they go along. I want to provide just a little bit of context for today's call, today's webinar, and for the series as a whole. So the setting for this, and most of you, I think this is not new to you, is the fairly rapid evolution of the role of citizen science in connection with government actions and decisions. Citizen science itself has been around for a long time. In the US, we have something, the Audubon Society, which is a bird group, started doing an annual bird count over 100 years ago. And I think that in the natural resources area is where citizen science really had its first role in supporting and informing government action, mainly in the sense of private citizens going out tracking wildlife and helping wildlife management programs manage and understand what's going on out in the field. But the movement of citizen science toward informing and influencing government action in a regulatory context is relatively new. We've had it in the United States, and that's my experience, so that's what I'll speak to. We've had that in the water program for a little over 20 years, primarily in the form of volunteers who help states go out and do water monitoring, taking samples, and then that data informs the official reporting that then informs some fairly major regulatory decisions to determine which waters are considered impaired and have priority for action. More recently in the water area, we see private individuals involved in monitoring for harmful algal blooms, measuring wetland health and some other developments. But that's relatively new and in relatively few states. Probably half the states have some kind of volunteer water monitoring program. The other areas are much less frequent. In air, the development has really emerged as a result of new technology and primarily the emergence of low-cost sensors that make it possible for private members of the public to go out and measure air quality in their immediate vicinity, which is a big change and is still very much in the developmental phase. It's the tools that are being used, and we'll get into this more later, are not equivalent to the monitors that are used by agencies, but they produce data that can be useful, and I think exactly where that's going is emerging. In the United States, it is increasingly common for communities that are trying to advocate, especially in environmental justice context, for communities that are trying to advocate for air quality are increasingly using these kinds of sensors as a tool. To a lesser extent, and this may be more in Europe, there's the potential for low-cost air sensors to be crowdsourced to do large-scale mapping that can inform decisions on a larger scale. So the development of the emergence of citizen science as a tool to support and inform and basically serve as a resource for government agencies is, I would say, rapidly developing and emerging, but it's still in the emerging phase. It's interesting, in 2011, INEAS put out a report on unconventional approaches to enforcement, and there was no mention of citizen science. So this is a relatively recent development, and that's why we decided that this is the time to have a deep dive. Today's session will be a broad overview of the field of citizen science and its interaction with government. Future sessions will look at air quality, water quality, the use of citizen science by indigenous communities, and so on. Another indication of the growing connection between citizen science and government is that both in the US and in Europe, our citizen science associations have formed law and policy groups, working groups or subgroups, and they are exploring where that potential lies. So we're hoping that for this audience, this will be an opportunity. I'm sure that some people here are totally on top of it, and for some people, this will be new. We want this to basically be an eye-opening opportunity to get you thinking about where the potential lies. So that's the setup, and now I want to hand it over to our first primary speaker. Our first speaker is Leah Shanley. Leah, you can now, I think, start sharing slides. Leah is a senior fellow at the Nelson Institute at the University of Wisconsin in Madison. She is also a co-chair with me of the Citizen Science Association's Law and Policy Working Group, and she's also a former co-founder of the U.S. federal government Citizen Science Community of Practice. So with that, Leah, it's all yours. I think you're muted.
There we are. Wait, can you hear me now?
Yes.
Excellent, thank you. All right, let's get that back. Slideshow. All right. Thanks, everyone. Yeah, so citizen science has actually been around for at least 100 years, if not significantly longer than that. But it's experiencing what we might call a renaissance in growing attention to how it might be used. The term citizen science originated in the mid-90s, independently by Rick Bonney and by Alan Irwin. Alan was in Europe, and while Rick had envisioned citizen science as being, the public assisting a professional scientist in the conduct of research, Alan Irwin had a broader vision of the role of citizen science to also inform public policy. So I ask you to start out, if you had 100,000 people to help you with your work, what would you do? And 100,000 people might even be a conservative number. Some projects are able to engage 1 million or up to 2 million people in some of their efforts. I'd like to first place citizen science in the context of open science, which is also a growing movement, both here in the US and in Europe and beyond. The OECD defined open science as a set of activities including open access to articles, lab notebooks, etc., open data, development of open source software and other open source technologies, open collaboration, which is where citizen science falls, and perhaps even open funding. For citizen science here in the US, the federal community of practice in the federal government defined citizen science, building on what was in the literature, as the contributions of the public to the advancement of scientific and engineering research and monitoring in ways that may include. And there's a whole range of activities spanning the entire scientific process. So I think we often tend to focus on citizen science for data collection, but we also could be engaging the public in helping us to identify the research questions, particularly that are relevant to local communities, to designing and conducting the investigations, to testing low-cost sensors, yes, collecting and analyzing the data, but also maybe developing some of the mobile apps, the low-cost technologies, and in some projects, they've been able to gauge the public in actually solving complex problems. Crowdsourcing is a related term, and in fact, there are several related terms: public participation in scientific research, community remote sensing, volunteer geographic information. So you'll see many different terms, and they're overlapping Venn diagrams. So crowdsourcing is a process whereby individuals or organizations put out an open call asking for voluntary contributions. It may or may not be explicitly around science or monitoring, but citizen science is one form of that. That said, while I'll be advocating for citizen science here, it's not always the right solution for solving every problem, but it can be valuable when applied appropriately and designed properly. So my colleagues in the federal community of practice and myself developed a schematic to kind of visualize the many ways in which members of the public might contribute to a scientific or monitoring program, from collecting samples, observations, photography, locations, to processing the data, image analysis, data entry, transcribing, annotating, classifying. And that's where we'll talk a little bit later about machine learning, as well as into problem solving. So why would you want to consider citizen science? Well, it helps us solve challenging scientific problems. And in some cases, it helps us solve problems we wouldn't have been able to do without engaging the crowd. It helps us to improve our spatial and temporal resolutions, increase our geographic extent or temporal scale. So if we have limited funding, limited staff, we can't be everywhere, but members of the public are living everywhere, except for maybe, rural areas. You would need more professionals out there, but it can increase our resolutions of the data we're collecting. It can help us with ground truthing, satellite imagery. It helps develop machine learning data sets, training data sets for big data. So there's any number of ways. And of course, hands-on STEM learning, increasing scientific literacy, environmental literacy, and awareness. There's some body of literature out there that it may reduce costs. The volunteer in-kind contributions can be enormous, as some studies have found. But then again, it's not free. We like to say, as Andrea Wiggins, one of my colleagues says, it's free like a puppy. There requires a lot of care and feeding and working with members of the public. You want to be engaging them. They're there not only for the science, not only to contribute to their communities and to the scientific enterprise, but they're there to connect with each other on a topic that's of great interest to them. There are a couple of, or many examples out there. One of which I'll highlight here in the US is Nature's Notebook from the US Geological Survey. They've engaged 100,000 volunteers or more, collecting 2.5 million observations of plants and animals that have been critical in chronicling environmental change and plugging into the models. We have a volunteer water monitoring network that connects 1,700 volunteer water monitoring groups across the country. A lot of interesting work that's being done in that space. And as George mentioned, there's also growing efforts in air quality, which I think Allison will probably touch on. We now have an ecosystem of citizen science organizations that are working to advance the science of citizen science, because we do care very deeply about the robustness of our contributions to the scientific initiatives. So we have a Citizen Science Association here in the US. Europe has a Citizen Science Association that emerged around the same time, as well as the Australian Citizen Science Association. And Martin's going to be talking now about a global partnership that has occurred. Within our US federal government, we also have a community of practice that we founded in late 2013, early 2014. So in citizen science, we have policy to support citizen science and citizen science supporting policy. So I'm going to touch a bit on how we develop policies and regulations to support the use of citizen science in our US federal government. So in 2011, when I was at the Wilson Center, we launched a project called the Commons Lab. And at that time, we were looking at the role of crowdsourced data collection for disaster management. But over time, I recognized that the same issues we were facing in the disaster space were very similar as we were using crowdsourced and citizen science and social media crowdsourcing approaches for environmental monitoring and other applications of the government. So I brought together over 100 people for a 101 in citizen science, and that kicked off just a movement within the federal government, where we formed a federal community of practice, and now under my colleagues' leadership, there are more than 350 or 400 members across 60 federal organizations. But we had a lot of worries at the start. You know, when you talk to scientists, when you talk to government officials, what are they worried about? Trust, credibility, and data quality, number one. Two, privacy issues was a big issue. How do we maintain privacy? When you're at the US EPA, as Allison's going to talk about, you're worried about being sued. You're worried about government or congressional oversight, right? So you want to make sure you're checking all the boxes, following best practices and standards, because you're concerned about liability. We also have some administrative bureaucracy that had to be overcome. And then how do we evaluate the effectiveness of these projects? So these days, though, there's been a lot of effort in the scientific community looking at citizen science and data quality and developing very robust methodologies for data quality assurance. So I encourage you to dig into some of that literature, and perhaps that could be a topic of a subsequent seminar. We also wanted to encourage champions, right? In each agency, when we started, there might be one person here in one department, another person in another department and agency, and they didn't know that they existed and that they were both interested in citizen science. Or you might have someone in EPA and someone in our US Geological Survey. And so our goal was to begin to connect these folks, to bridge between the silos, and to cultivate champions in each agency for the appropriate use of citizen science. We engaged our policymakers and our lead agency executives, from the President's Science Advisor, John Holdren, to the head of our National Science Foundation, Francis Cordova, Bob Pertusepi, one of the leads of the EPA, and Rush Holt from the American Association for the Advancement of Science. So the leading scientists, the leading agency scientists, getting their support to provide that air cover to government employees as they proceeded to use this kind of project. But how do you get started? A lot of our folks didn't know where to start. So we mobilized 125 federal staff with zero budget, I might add. It was all volunteer effort to build a toolkit, basically how to step by step, how do you design a project? How do you manage volunteers? How do you evaluate? Developing a set of case studies for how the citizen science approaches might be used effectively within the government context or through government funded projects, and then a resource library. Trying not to create a kitchen sink, just here's the core places to get started. We worked with the White House to develop a memorandum of, through the Office of Science and Technology Policy that set about 3 core principles: data quality and fitness for purpose, openness and transparency, and meaningful public participation. This was built on the European 10 principles of ethical use of citizen science. So we were learning from Europe in this, and I would like to see us here in the US develop out a set of principles as well. But this provided at least some initial guidance. It was something that we could get through with consensus fairly easily. And we assigned citizen science coordinators in each agency to be at that point of contact within an agency and between agencies, and developed a catalog of citizen science projects. We worked on some legislation. It actually started a conversation I had with a Senate staffer in a bar, and progressed fairly quickly with the help of many colleagues, including the Citizen Science Association and SciStarter, that advocated on the Hill to get this legislation passed. And then looking to increase funding opportunities. So looking within each agency, can we develop new funding programs to support citizen science initiatives? And can we build citizen science into different policies within the federal government? From the Open Government National Action Plans, to the President's Strategy for American Innovation, to the National Civil Earth Observation Plan, and the Global Climate Change Assessment. Today, I'm very excited to see that agencies like the National Oceanographic and Atmospheric Administration are developing agency-wide strategies for citizen science. NASA, USGS, or other agencies considering this. NOAA just put out a call for public comments, to which we responded. And I think there's wonderful opportunities here to integrate citizen science with the other strategies the agencies are having, including on artificial intelligence, unmanned aerial systems, data strategies, and cloud strategies. What are some of the emerging trends briefly? Well, we now have a host of resources for projects to go to for, clearinghouses where you can find projects in the US through SciStarter or the Federal Community of Practice Catalog. In Europe, our colleague Sven Schade at the JRC has developed a wonderful catalog of citizen science projects in support of environmental policies. There's also now platforms to store citizen science data, so like my colleagues at citsci.org. And there are platforms like Zooniverse, and this is for crowdsourcing science, that allow you to modularize online projects to engage millions of volunteers across the globe. I think there's an emerging area of the integration of citizen science or human computation with machine learning, the development of training data sets for example, the interpretation of Earth observation data. Citizen science can provide that ground truth. They can provide the data for the calibration validation. Low-cost sensors, which I think Allison hopefully will be touching on a bit as well, but from wearables to balloons, to your sensors, to sensors that can be put on a cell phone. There's a whole array of low-cost sensors out there that are making it easier than ever before for the public to engage and collect data. The question, though, will be how do we also maintain data quality as a part of this, and also some of these sensors biofoul fairly easily. So how do we make them sustainable and robust against the elements? And how do we evaluate things over time with that? I think there's—
Leah, if I can just give you a time check, maybe.
Yeah, I know, I got 1 minute.
2 minutes. Yeah, okay.
Yeah, Earth observation strategy, the group on Earth observations. We have a citizen science working group there beginning to look at this. In Europe, you have the citizen science observatories, which are very comprehensive platforms for citizen science engagement, including the cyber infrastructures. I think this is something the US could learn from Europe. And then I've provided some resources, particularly our colleagues at the JRC have a great article, a report out on best practices in citizen science for environmental monitoring that just came out. There's a special issue of the Citizen Science Journal that looks at citizen science for public policy, including some environmental applications. and then a new focus on citizen science and the UN Sustainable Development Goals and the Aarhus Convention. And with that, we can certainly follow up during questions. Thank you.
Thank you, Leah. I can already see a trend in the graphics, which I think we'll see again later. That's great. This was Leah did a very broad overview. We're now going to move into a focus on the U.S. Environmental Protection Agency and citizen science there. And we'll be hearing from Allison Parker. Allison is a senior program associate at the Woodrow Wilson Center for International Scholars, and she's a board member of the U.S. Citizen Science Association. Let me just say that, as Lee mentioned, our plan is not to take questions after each speaker, but to have a really robust panel discussion for the last half hour. So keep sending questions into the chat. We'll monitor those. We'll come back to them after all the speakers are done. So over to you, Allison.
Excellent, thank you. I'll just share my screen here. Great, it is great to be here. I'm really excited about this seminar series, and I plan to attend the rest of them. And it'll be great because a lot of the future sessions will be building off of many of the things that we're mentioning today. As George mentioned, I'm Allison Parker. I'm at the Wilson Center in their Science and Technology Innovation Program. And previously, I was a fellow hosted by the U.S. Environmental Protection Agency on their innovation team. And prior to that, in fact, I was more in the ecology field. And as George mentioned, citizen science having a rich history in natural resources. My experience there, actually using citizen science for ecology research that I then brought to EPA and then to Wilson Center. So I will be touching on many of the same themes that Leah did in her presentation, but with a bit more of a focus on environmental protection and sort of the perspective of the United States Environmental Protection Agency, as well as just environmental protection individuals and organizations, again, mostly with United States focus. I'm looking forward to hearing from Martin later about some more international perspectives. So again, getting into sort of like, what are we talking about here? I think from an environmental protection perspective, much of the time when we talk about citizen science, we're thinking about things like, as George mentioned at the beginning, and also Leah, the use of low-cost sensors for monitoring of local air quality, with a community perspective in particular. And also efforts around the country and obviously around the world, looking at volunteer water monitoring of water bodies locally. And there's a rich history here of local and regional organizations contributing to environmental data about water quality. And there, George mentioned this as well, that there is a long history of cooperation between these organizations and state and federal environmental protection programs, as well as examples of these data being integrated into data sets that are used for decision-making, like impaired waters. So I think it's interesting to look at air and water and the both similar and divergent history of how they are considered within sort of the decision-making sphere. And of course, there are many other types of citizen science or community science, including an example of a project that worked with communities to test for contamination in fruits and vegetables from home gardens. That's called Garden Roots. So that's just one example of a variety of other kinds of citizen science that are highly relevant to environmental protection. And as George mentioned, much of this work is focused on environmental justice, and that's hugely important for putting it into context. I'll mention that when I think about citizen science, and Leah mentioned this as well. I think about mainly more sort of institutionally driven work, whether it's coming from an NGO or a university or an academic setting, or potentially even a government agency setting, such as a project run by an EPA scientist. And much of the time when we talk about citizen science, that's what we're referring to. And in addition, we also think a lot about community science, which sometimes is also like brought into that overall umbrella of citizen science, with community science being specifically those efforts that are either collaboratively led or driven by communities themselves, and addressing community defined questions, thinking primarily about what's important to communities rather than necessarily what's important to scientists and institutions. So again, these terms can be interchangeable, but also I think have distinct meanings in terms of how they're initiated and how they're run. Just a few quick points about citizen science, and I'm thinking about both citizen and community science here. We've seen from previous speakers the extent to which the scientific contributions of citizen science are increasing. This is a graph showing sort of exponential increase in just the phrase citizen science within scientific publications. So it's becoming more and more well established within scientific fields. And George put this in perspective really well, that integration is now expanding into this decision-making realm. So, and I'll also mention that oftentimes we think about citizen science as being a sort of unique, distinct field or method, but in fact, citizen science can be highly integrated into what we think of as just general scientific research. One example is a paper by my colleague Karen Cooper, who looked at citizen science in global research on migratory birds and climate change, and actually found that up to half of that research, or of the main conclusions coming from that research, were informed by citizen science approaches, but citizen science was not mentioned even once in these publications. So a lot of times it's built into that rich history of data collection with the public, such as the Audubon Society data set that George referred to. So I think, and this I think is certainly true, especially in the water monitoring area, that the contributions of citizen science and community science is often underappreciated and invisible when it is in fact there. So moving into thinking about the conversation of citizen science at the Environmental Protection Agency and other environmental protection organizations in the US, I think over the last 5 or 6 years, there's been a big increase in the amount of conversation happening around citizen science in regulatory agencies and other organizations. A lot of this was spurred on by the work that Leah mentioned in the executive branch of the US government, and the major push by the Obama administration that started with this memo from John Holdren, the head of the Office of Science and Technology Policy, to executive departments and agencies, which really spurred a lot of conversation and development about citizen science in federal agencies in the US. Following that was a bill that passed in 2017, early 2017, I think, that really encouraged the use of crowdsourcing and citizen science within federal agencies along the same lines as that Holdren memo, which I think did more than just what is laid out here. It really signaled the enthusiasm and importance of citizen science in federal agencies, and communicated that sort of top-down support that has been extremely helpful for generating conversation about how citizen science is perceived within decision-making. So now I'll talk a little bit about work and conversations happening at the US Environmental Protection Agency, because I think it's a good sort of model for how other agencies and environmental protection organizations may be thinking about citizen science. There have been a number of important initiatives over the last 5 or 6 years, again, beginning with that executive agency, or sorry, the executive branch sort of push for citizen science within the context of open government and open science that Leah introduced. One thing that I want to talk about fairly in depth, because I think it's a really good framework for thinking about citizen science for decision making, is 2 reports from the National Advisory Council for Environmental Policy and Technology, which is an advisory council to the US EPA. And this advisory council represents 28 representatives of many different sectors and parts of the United States. And these representatives came together to provide EPA with advice and recommendations about how to consider the use of citizen science for environmental protection. And their resulting report, the first one, was in 2017, I think. And the quote here, they really identified citizen science as an invaluable opportunity for EPA to both strengthen public support and to connect with the public. So really recognizing the opportunity that citizen science and community science provide in terms of opening those communication channels and building support with the public.
So Allison, you're doing fine. If you can aim for about 3 minutes.
Sure, thanks. I'll just run very quickly through the overall recommendations from the NACEP report, again, because I think they're good framework for really any environmental protection organization in the sort of decision-making realm. They talked about embracing citizen science as a core tenet of environmental protection. And a lot of that was thinking about how to define and communicate the role of EPA in citizen science. How can EPA support and build on efforts in the external world? The importance of investing in citizen science. Again, as Leah mentioned, it does not come just for free, that it needs dedication and sort of long-term thinking. I think most importantly for this conversation, the recommendation to enable the use of citizen science data that's sort of just reacting to data coming in from, in particular, community science projects is not what needs to happen. There needs to be more sort of forward-thinking communication of what is needed from citizen science and community science projects to allow those projects and initiatives to meet the standards of for whatever use the data can be used for. So that includes adopting standards, adopting a positive and cooperative agenda to increase utility, and really just providing that guidance and communication about the data quality needs for any particular use. I'll skip this one and jump right to this graphic that represents, this is from that NACEP report, but it represents the wide range of uses of citizen science data. I think many people are used to seeing citizen science sort of over here on the left-hand side of this spectrum, thinking about citizen science in terms of its very obvious uses for community engagement, education, and potentially even indicating issues. But then as we move more towards the right, I know this group is highly interested in citizen science for the use of, for regulatory decisions, regulatory standard setting and enforcement. And so one of the main ideas of the NACEP report is thinking about how citizen science may move from the left side of this spectrum more towards the right side, and what are the necessary, again, standards and guidance and communication that's needed for that shift to take place. Their stance was sort of that this is inevitable, and I think others on this panel may touch on this as well, that in order to really take advantage of this overall shift in the way that environmental data is collected and used around the world, we should be forward thinking and think about how this shift can happen most productively.
So Allison, if you can just take another minute or so.
Great. So since that NACEP report and a following report after that, there have been a number of other EPA initiatives that have further clarified and started to think about overall strategies for the use of citizen science in this context. One is a report from the Office of the Inspector General that I think really drew from that NACEP report, but also recommended that EPA needs to think more broadly about citizen science and needs a comprehensive strategy. And then following that, EPA released a citizen science quality assurance and documentation handbook, which I think has been very useful for, again, starting that conversation about what the standards are, what are the needs for data quality, so that citizen science and community science can be more productively used and again, be a good communication tool. I'm sure the rest of this conversation will touch on a lot of these points that came out in the paper that Lee mentioned at the beginning that I worked with him and George. And a number of drivers of citizen science on decision making have been mentioned already, including technology, a shift towards thinking about local and neighborhood scale problems, and in particular, the enthusiasm for citizen science, including those on the ground collecting data as well as formal support in government. And I won't get into this. I'm sure we'll spend the rest of this discussion thinking also about barriers that Leah also described. I think obviously general skepticism about data quality, which we'll get into more, uncertainty about how technology changes data collection and what we need to know about that technology, and legal barriers. So I will leave it there, but looking forward to your questions and discussing this further. Thanks.
Great. Thanks, Allison. As you said, I think a lot of these points that you're making, these are going to weave their way through the discussion later and certainly in future webinars in this series. To move along as quickly as possible so we can get to the conversation, I'd like to introduce Martin Brocklehurst. Martin was a founding member of the European Citizen Science Association and the International Global Partnership for Citizen Science. He is also, relevant to this audience, former executive manager of the England and Wales portion of the UK's Environment Agency. So very cognizant of the interplay between citizen science and government. So handing it over to you, Mark.
Thank you, George. I'm going to charge straight in on the presentation, and the slides that support this presentation will be made available after the event, so some of the detail you will be able to pick up. I wanted to just start by saying that we're the generation on whose shoulders it rests to find and implement the policy solutions that will resolve the greatest environmental challenges of our time. We have triggered catastrophic climate change, which is real and accelerating, and biodiversity decline, which shows no sign of diminishing. Our demands for resources from our planet continue to spiral upwards in an unsustainable way, and the use of fossil fuels leads to poor air quality that continues to prematurely kill millions of people. And if I can get my slides to move on. My slides are not moving. I have no idea why. There we go. So that we have this burden in terms of air pollution. So to this burden, we've now added a global pandemic that has illustrated just how interconnected our world now is and how poorly prepared we are to respond. Yet we have the policies, the programs and international agreements in place that will solve these problems. What is lacking is effective implementation, monitoring and enforcement at global scale. I want to inspire you today that citizen science can make a difference and help you to achieve your environmental goals, and in the process, scale up local solutions into global solutions. I want to convince you that citizen science at scale can improve enforcement and compliance by building partnership with citizens, strengthen the capacity of the regulatory cycle, to implement and secure compliance with environmental requirements, and to secure the active support of citizens for your work to deliver environmental compliance and in the process encourage behavior change towards sustainable development by your communities. And again, the slides are still not moving on. Anybody know why? There we go. This slide from Australia illustrates why I think citizen science is crucial to humanity's future. In 2019, I attended an inspirational meeting at the UN Science Policy Business Forum in Canberra, Australia, where citizen science was given a central platform with some of our biggest global companies, with leading experts on remote sensing and with global leaders from the UN. Listening to the key scientists at this forum talking about the growing level of greenhouse gases in 2018, I was struck by the view that science is not enough to convince our policymakers that rapid change is needed. At the time, the Australian bushfires were just starting, and as I flew home, I went over the Murray-Darling Basin for hours, and the consequences of climate change were rammed home. Below me, Australia was experiencing its largest ever spring fires, the highest ever temperatures recorded, and a drought worse than the Millennium Drought of 1996 to 2010, itself the worst drought experienced in Australia for over 100 years. I could see no water for hours, and communities in a fully developed country were running out of drinking water. Rivers that carried cargo vessels were drying up, and the country was choking on smoke. As I left, it got worse, and lives were lost, livelihoods and communities were destroyed. Yet the lessons have not been learnt. This year, we're seeing a repeat of this catastrophe in the western states of the US, where the worst forest fires ever experienced are now taking place. And two comments at this time drove home to me why citizen science at scale is really important. The first was from Dr. Tom Beer, who was a pioneering researcher in the 1980s into bushfires and climate change. And he said, I suppose I was young enough to believe that doing the science was going to be enough and miraculously people would act on it. It's a naive view. I think it was fairly common at the time. And then while I was in Australia in 2019, public officials were issued with advice not to discuss the link between climate change and bushfires. And that's one of the reasons on that previous slide you saw what the reaction from local community leaders was. If I needed more inspiration, that we needed more than scientific evidence to drive rapid policy change, this was it. It strengthened my belief that science is not enough. We need citizen science, and we need citizen science at scale to drive rapid policy change and overcome entrenched economic interests that continue to deny reality as fake news. We need to change the narrative, and I believe this is possible through citizen science, which is growing at exponential speed, as you've heard. In Europe in 2013, pioneers in large-scale citizen science at the time, such as Linda Davis at Imperial College London, who inspired my interest in citizen science, Dr. Jacqueline McGlade, then the CEO of the European Environment Agency, and subsequently chief scientist at the United Nations Environmental Programme, and Janusz Potocznik, the former Environment Commissioner within the EU, recognized the potential of citizen science to drive policy. They understood that if you attracted 10% of the population of Europe to engage in citizen science, not only would we build the scientific evidence base to support the policy changes we need, but you would encourage behavior change in our people and drive the political process to overcome entrenched interests. After the launch of EXA, I was given access to senior policymakers in the EU, and very quickly they made it clear to me that they didn't see how citizen science was going to help their particular agenda. And the usual arguments that it doesn't provide statistically reliable data, it doesn't cover a sufficiently large enough geographical area, it's not covering policy areas relevant to the EU, and it didn't help with the reporting on the Sustainable Development Goals, but came to the fore. These examples on the slides now, I believe, are no longer relevant. We have, in effect, overcome many of these obstacles. We have evidence to show that citizen science is cheaper, quicker, more agile, and just as accurate as conventional science in understanding and monitoring environmental and related health problems, and this in peer-reviewed journals published in major scientific journals. It's peer-reviewed papers in major scientific journals. And we also have the fourth industrial revolution, the possibility of billions of people connected by mobile devices with unprecedented processing power, storage capacity, and access to knowledge which are unlimited. And these are the words of the World Economic Forum. It is why citizen science, in my mind, is the future, because you can obtain levels of data that are impossible to obtain by any other method, by people who are directly affected by the issue. We also have the potential to link citizen science with global spatial observations to increase the power of both unconventional data sources in terms of the Sustainable Development Goals, both with really exciting opportunities opening up, particularly in the field of water quality monitoring and land use change. And it's why in the EU we now recognize the power of citizen science. We've moved on from those early years in the policy cycle. And we have already got a whole string of publications, which you can look at your leisure here, which document the growth of citizen science in the policy agenda for the EU. And we now have the opportunity to integrate citizen science in each of the policy segments of the development of policy, the implementation of policy, and the monitoring of policy within the EU. And the first real example where citizen science data has been plugged straight into legal obligations. This is on the EU legislation to ban certain single-use plastics. And the basis of the decision to ban these plastics was citizen science research on marine litter. To support the global potential of citizen science, we're now working with a whole string of global organizations, as you've heard. But we've set up since 2013, not just associations in the developed North, but we now have associations in Asia, Africa, and coming together of an association in South America. So these are links that it would, regardless of where you operate in the world, that you can plug into and take advantage of. And at the global level, with the encouragement of the United Nations Environmental Programme, the associations have come together to support the Citizen Science Global Partnership. So developed with guidance and support from UNEP from 2015, when science was not even in the vocabulary of the UN, to a position today where we're invited into the heart of the organization. And the aims of the Citizen Science Global Partnership are shown on this slide, and you can look at these in your leisure in due course. But I think the important thing about the work we've been doing with the UN is that it led in 2019 at the UNEA 4, which is the United Nations Environment Assembly number 4, the highest environmental decision-making body on the planet, where citizen science was recognized as an unconventional data source that could make a significant contribution to the delivery of the UN Sustainable Development Goals in the Ministerial Declaration. That means for the first time ever, environment ministers across the planet signed a declaration that recognized the role of citizen science and committed to raising a framework for supporting citizen science in the reporting of the Sustainable Development Goals. And as a consequence of that, we now see a whole string of global organizations and regional organizations working out how to build citizen science into their programs. And if you look at this slide in your leisure, you'll see opportunities in UNESCO on their recommendations on open science, which integrate citizen science into changes that they propose. Changes proposed in the Aarhus Convention to build an element of citizen science into that convention, which covers Europe and a number of former Eastern European countries. The G7 Science Academies Declaration on Citizen Science, the World Economic Forum Declaration on Citizen Science in the Data Crisis, and so forth. And I believe that the time has come to build on the foundational goals of the Citizen Science Global Partnership, to put in place a global convention on citizen science to be adopted by ministers at the resolution of either UNEA 5 or UNEA 6, depending on how long it takes to work through this particular process. To enshrine rights for citizens to collect data for citizen science programs, and also to protect the interests of scientists who take part in the participation and the collection of data. And as you move in different countries across the world, you'll understand why it's important that the support is given for citizens who participate in this type of work. But I also think it's really important that we start to coalesce around citizen science programs that have the power to expand our understanding on the great issues of our time, engage our communities in finding solutions that will drive behavior change and accelerate policy shifts at a global scale. I believe this is possible and that we can engage millions of people across the planet in citizen science programs that will deliver a future for our planet. I'm encouraged by programs that are already starting to move in this direction, such as the Global Mosquito Alert Consortium, which is tracking the changing location of mosquitoes that are potential vectors of disease as they migrate into Europe and the USA. I'm encouraged by the way citizen scientists are cooperating to standardize best practice methods, data gathering systems, hardware and software, so that anyone across the globe can take up an example from the Netherlands or for Italy or from Spain and apply that in the developing South. And we have our first example here on this particular program, where the mosquito alert program from Spain was transferred into Pakistan, and the whole package was simply lifted, translated, and applied in a different country. We also have examples in the air quality area now from Europe, and particularly Curzon-Neersen, where roughly 5% of the population of Flanders became involved in air quality monitoring. Up to 50,000 people using highly reliable technology, integrated and calibrated back into the formal air quality monitoring system.
So George,
Martin,
yeah,
on our end, you seem to have frozen up here.
George, I think we can maybe pick up some questions until George is back on the line. So if Avi and George, you want to do that, that might be a good approach.
Okay. Yeah, Martin, pending, give us a high sign when you're back live. We've got a lot of great questions, and I wouldn't even know where to start. Avi, are there any that have really jumped out at you? I think Avi, you are muted. All right.
Sorry
well,
about that.
I will pick one that was made early on, and it's such a big fundamental question that we could probably spend the rest of the time on it. But I'm now looking for it. But the question had to do with the reliability of data, the fact that citizen scientists may have an agenda. I think this gets into the general question of scientists being very wedded to a sense of neutrality when they do their science. And yet, if we talk about citizen science for policy, the people that are coming forward are often not coming from a position of neutrality. I don't know if I captured the question correctly, but anyone want to react to that? How do you deal with that question of people who are passionate, devoted to a cause, and then coming forward with their data?
Yeah, the question, I wrote it down because it was flagged for me. How do we insulate against misinformation, public perceived ideas and political agendas that may impact how the data is collected? So I think following a robust scientific process, following shared international standards for data collection, instituting very robust data quality assurance methodologies, a lot of training. So there are projects like COAST, that's COASST, I think, or at the University of Washington. They require that volunteers be participants for a year. They put them through very rigorous training. Their quality assurance standards are so that it could be used as evidence in a court of law. So that's one example where they're working to mitigate any possibility of misinformation or political agendas being introduced. Allison, you wanna?
Yeah, thanks. I would sort of push back on the sort of context behind the question. I think that we insulate against misinformation and notions and political agendas from citizens sort of in the same way, as Lee mentioned, as we might against scientists having misinformation, public preconceived notions and political agendas. I think many of the tools that we have sort of in our scientific toolbox are useful not only in traditional scientific settings, but within the citizen science world as well. And I think that the notion of sort of traditional science being free of political agenda and just not being political is a bit of a stretch. So I think it's sort of putting all into context and using the tools that we have for transparency and for documentation of data are all going to be useful. Also thinking about scientific research as one tool of many. So not scientific research as a whole, but any particular scientific study is not going to provide us with 100% of the answers. So thinking about, following up a citizen science initiative with maybe some regulatory research or scientific driven research to provide different sets of information that can then be used for drawing conclusions and decision making, I think is a useful approach.
And George, I might just point out that as we all know, there is an extremely broad range of activities under the citizen science umbrella. And the piece that was pointed out about Belgium and 50,000 people doing air quality monitoring, it's pretty hard to see a political agenda there. It's a data gathering agenda. So I think it's important to look project by project, approach by approach, to see where citizen science can fit in with a regulatory agenda or an enforcement agenda.
Well, and when you have 50,000 people versus 10 graduate students collecting the data, your statistics are going to be a lot better. And hopefully you can catch those outliers or misinformation that may be introduced. But it is a serious topic, and it's something I've been tracking since I was at the Wilson Center. There was a project run by DARPA, the Shredder Challenge, where they did have a nefarious actor introduce misinformation into the crowdsourced system. And so now the discussion is, how do we develop systems that identify these kinds of false inputs, track them, mediate for them right away in real time.
George, I saw a question come in on environmental justice, and I think it's an important one to address. I know that some of the case studies you did in the US really focused on projects that were designed around environmental justice, and especially in the air quality area. The traditional monitoring doesn't get to the neighborhoods or communities. So some of the new monitoring technologies allow us to kind of deal with environmental justice in a different way. And maybe the panel would want to comment a little bit on that. I see Martin's back with us now.
Yeah, I see Martin's back. I will take just very briefly a quick response to that, and then we can let Martin pick up again. Environmental justice is really a prime area in the U.S. And this is, I will say, not driven by the agencies. It's driven by the communities that have found that these tools exist. Often air quality is one of their main concerns. The question asked about specific examples, and I think we can put that in the chat or in follow-up. It's certainly an area where there's a lot of learning to be done, and there have been some successful and some less successful examples, but a very important one for the U.S. So, Martin, I'm delighted to see you back. Are you ready to share your screen? Do you need another second?
Yeah, I'll do that, George. Sorry about My internet dropped out for some reason. I have no idea why.
Okay. And let's see, at the point you dropped off, I was going to give you about a 5-minute warning. So if you can,
Okay.
that gives you a general range. That's
Yeah, that's great. Okay. What was the last slide that people saw? And again, I'm having trouble getting this to work. Let's see.
Martin, if it's not working, maybe just give your verbal comments.
Yeah, I was just trying to see what the problem was with the screen, why the slides are not advancing. What was the last slide that people saw, George?
well, this is so now I'm getting a quiz. You had done the one about the crowdsourcing on air quality in the Netherlands, and I believe there was one after that.
Okay, so what I was going on to talk about was the last example was from the current pandemic, where King's College London have developed what's called the COVID-19 Symptom Tracker citizen science program, which has now drawn in over 4.5 million people reporting and taking part in scientific experiments in the UK, Sweden, and the USA. And this latter program has pioneered the crowdsourced funding, raising over £1 million to keep the program running in a little over 2 weeks. Not once, but twice, at a time where the UK government refused to support the program. But the scale of the involvement and the quality of the data being produced has forced a change in government approach to one now where a further £2 million has been added to the study by the UK government. The program is both a useful operational data source in providing a method to spot and control outbreaks based on symptom reporting and machine learning, a source of scientific research, and provides the users with data they can use in their lives to manage and reduce personal risks from the virus. What these programs illustrate for me is that when you bring together health and environmental research, ordinary people across the spectrum will engage in large numbers. So my final appeal to all the people listening would be for you all to start your journey, to explore your work programs and look for opportunities to integrate citizen science into your monitoring, compliance, and enforcement programs, and get involved with your communities in delivering the policies all your governments have signed up to at the international level, and that you will be rewarded by building new skills, forging new partnerships, and sparking an interest in our planet with a diversity of people across all social spectrums and age groups. You will tap into a level of energy and drive that is a joy to behold, and will find new ways to solve old challenges. And my final thought is that we cannot fail in this endeavor. We must not let the light go out on the only known planet with life in our universe because of our inaction. And I apologize that you can't see the slides to go with that. So thank you very much.
Well,
there we go. They're starting to work now.
Yeah.
This is just really giving you the example of the COVID symptom tracker. And this is the type of thing that people see on the app, on the mobile phones. And this is the type of thing that's being predicted. And that's the type of thing that you get out from the app. This is showing the latest data in the UK on the incidence of COVID and the number of daily cases predicted based on symptoms and not on actual tests. And of course, the algorithm that's behind this has now been calibrated against real tests and shown to be very accurate, and has now been exported as a franchise package into Sweden and is also used in parts of the US. And that's just a list of all the organizations involved. That was just to say citizen science can be fun. And then lastly, this was looking back on the Earth, which is the tiny blob in the middle from the edges of our universe, to say how important it is that some of these really big issues can be tackled through citizen science. So thanks everybody very much.
Well, thank you for that really inspiring talk. Yeah, it really puts it in perspective. And thank you for introducing the topic of COVID, which reminds us that the opportunities for using citizen science are always expanding.
Well, I think I would say, George, on that COVID one, that that piece of research actually identified a new early symptom for COVID-19 that nobody else had found. So this is actually now, there's been about 15 or 18 peer-reviewed scientific papers that have been produced on the back of the research being done on the COVID-19 symptom tracker. And I think that the people involved can hardly believe how fast it has grown and how successful it has become. And it's because it's hit that sweet spot of an issue that affects everybody's daily lives. And they feed back to people information that they can use to help risk manage where they go and what they do in the community. So there's a two-way flow going. It's classic citizen science for me. It's a tremendous scientific value, but it gives something back to all the participants to encourage them to come back in on a daily basis.
Yeah, I think that two-way flow, that's something that we hear from others that, you know, in the past, as the earlier presentation showed, citizen science it's often been a one-way flow. There's a group outside the government that gets concerned about something, brings data in. Government may or may not act on it, but then that's kind of it. It's kind of flown in. The flow back to involve the citizen science and make it a true partnership, I think, is where we are on the you know, that's really the next step.
If people want to look on, look on the website, you'll see on that particular website all the data that's available. But what's quite nice is that there is publicly available data and data only available to the participants who take part in the program. So the participants will actually see on a daily basis the reports that are submitted to the government, in addition to the public information that's available on the predicted number of cases in each district region of the UK. And it's been used in an operational sense to identify hotspots in the disease around the UK, and policy actions have followed immediately as a consequence. A really good example in Wales was where they identified a hotspot of the disease in an area where you would not have expected it. And they found it related to a campsite, and they promptly closed the campsite because it was people coming into the area with the disease.
Yeah.
We have about 50 minutes left, so we need to move on to other questions.
Yeah, thanks, Lee. One that came up earlier, I think we can answer it fairly quickly, but someone said, well, how can I participate in citizen science efforts if I'm not trained in scientific work? Can I do other kinds of help like writing? And I actually responded to that one privately, but I might as well respond to the larger group, and I'd invite the rest to respond. Actually, kind of by definition, citizen science or community science relies very heavily on people who do not have scientific training. That's almost definitional. And the efforts that I have seen most invest very heavily on training those who do not come to the effort with scientific training, providing the training because that's necessary to have quality results. So people should not view that as a barrier. If anything, that's the way these programs are designed. Another question that came in, and this is tough, maybe others have better answers. What efforts are underway to ensure equity in funding so that monitoring occurs where the pollution is actually happening? And this is a frequent concern that the communities that maybe have the time and the private resources to do this may not be the ones that have the greatest needs. So do any of the panelists have thoughts on how to address that concern?
Maybe let Martin talk first, because he was an actual regulator.
Yeah, I mean, what I think I would say is the Curzon-Nerzan example is a good one, where what they've done is they've taken a very robust method for monitoring air quality. They've actually used passive diffusion tubes, and they've made them available across the whole city of Antwerp, so regardless of district. And because you're actually using people who live there, they can deploy these monitors in places where they would disappear if they were employed by official sources. You know, one of the problems of putting in socially deprived areas is unless you have some ownership with the community, the monitors that you're using very often just disappear. So if the technology is simple enough and it's explained to people how to use it, you can actually do a fantastic program with citizen science and air quality. One other I didn't mention, another one I really liked was one done by the Antwerp University, who actually used strawberry plants to work out what the air quality was over a time period during the summer growing season. And they analyzed the contaminants in leaves of the strawberry plants that came back from the participants. So everybody was given a strawberry plant. And the amazing thing about that is it generates a smile on people's faces, and they can actually keep and eat the strawberries. And they were able to do that across a very large area of the city. And both these programs have challenged the air quality models for Antwerp. They've actually identified new problem areas for air quality. And as a consequence of that, they're recalibrating the models that they use. They've also seen a change of behavior. So people are starting to avoid pollution hotspots, air pollution hotspots in the city. And then when I was talking about this at UNEA 4, the Belgian ambassador came behind me and made it absolutely clear that this program had done far more than just monitor air quality in the city. It had actually changed the debate in the city from one about migrants at the time to air quality. And people were demanding of their leaders that there was a change in attitude to tackling air pollution in the city. And it led to political change in the city as well. So this is very fundamental stuff.
Thanks, Martin. Sorry to interrupt. I want to make sure.
Yeah, that's fine. Yeah.
Allison, did you have something you wanted to add?
Yeah, I'll just jump in. I think that's a really great question because I think a lot of citizen science and community science, or citizen science efforts in particular, are working on equity and participation. But I think that equity and funding is still a future priority that we need to address. I think a lot of times the barrier comes from requirements from funding agencies and others that funding be given to sort of established institutions, whether it's an academic institution or a formal 501c3 nonprofit. And sometimes these institutions have community partners, but oftentimes they do not. And even when there are community partners, sometimes they're not treated equitably. So I think this is a really important conversation to have moving forward. How can we build in more opportunities for equitable funding, maybe by removing some of those requirements for very institutional, formal organizations leading these efforts.
And George, I want to add a great response, Allison. Johnsine Cockman noted that USDI assistance agreements require the citation of specialist orders, but don't include open science or citizen science secretarial orders. Martin, is that something you're familiar with, or folks from UI that can comment on? Because that sounds like something to do with the community partnerships there.
No, I couldn't answer that one. But what I think I would say is that one of the problems we've had, I think, in citizen science is a lot of the work that has been done has been project work. So what you find is it's a university that gets some funding to prove a particular citizen science technique, that it adds value to the data that's being provided in a particular area. What I think Curzon-Neursen did, which was a little bit different, is it actually involved the regulator in the whole process. So the regulator was using citizen science as an extension of what it was doing. And therefore there's an opportunity to build baseline funding into the program. And we see this in other regulators like the Scottish Environment Protection Agency, where they've looked across their business and they've said, how could we do this differently? How could we use the money that we have got for monitoring activities in a different way by involving citizens? And can we get more data that way? Can we get a better spread of data that way than we would through conventional means? And that's building citizen science into the day job. And for me, that's what the longer term ambition needs to be. I'll give you one last example, then I'll be quiet, George, which is water quality monitoring in Australia. I had a conversation with one of the water companies there who said to me, we've been doing water quality monitoring for 15 years with citizen science volunteers. It's a great program. But one of the problems it creates for us is it creates too much data. And I pressed him a little further and said, well, what's the problem with too much data? And he said, well, we have to QA the data. So, you know, my stretch question back to him was, well, think differently. Look into your citizen science community and work out if there's a cohort of people who can help you with the QAing of the data. And then it later turns out that most of the monitoring that's being done has been done by retired employees from the water company who actually have a knowledge of what's required anyhow. But it's about this. Don't be suspicious of the data. Don't try and do everything within your own resources. If you find it's scaling things up in that way, look back to the citizen science community to help you with the QAing of the data that you're obtaining and also the management of the data. So thank you very much.
Great, great. Thank you, Martin. Lee, it looked like you had something you wanted to add on the equity point.
Well, I just, I think that's a continuing problem, and it's one that the government agencies need to think about as they think about what their monitoring programs and where their resources are spent. So, sometimes like the multiple air toxics emission studies in Los Angeles, government identifies a problem in a community and puts some resources into it. That's an ongoing, I think an ongoing issue is to figure out where the resources are going to be available for bringing the community into the discussion.
Yeah.
George, perhaps let me give you one other example of this. I think when you go to parts of the world that have got insufficient resources to do the scientific research and monitoring work that's required to report against the Sustainable Development Goals. There's a really good example now in the South Pacific Islands, who have turned to citizen science as the only way that they can get the data that they require to report back on their performance against the SDGs. So it's not a case of I've got an existing program and I'm looking for citizen science to complement it. It is I have no way of delivering the requirements against the SDGs unless I do it through citizen science. And they're drawing in indigenous knowledge around the whole issue of fisheries. They're drawing in indigenous knowledge and reporting on emergency response planning, on a list of health issues as well. And so the whole program has been designed from day one as a regulatory citizen science program that's of benefit to both communities, both the participating indigenous population and also the government. So this is not just about the developed North. There are fantastic opportunities for the developing South.
Okay.
I think we have time for one more question.
Yeah, Lee, I thought I would actually, given where we are right now, I thought I might use that as a segue to a little foreshadowing of some of the future sessions in this. We've had some really good conversation in the chat, which tells me we have a sophisticated audience here, and we will want to think about how to keep that conversation going. The point about the indigenous population is not just the global North. This is something that we're trying to be attentive to in this series. The next 3 sessions, the next one in 2 weeks will be on water issues. The next one after that will be on air. The one after that, so in 6 weeks, is focused on the use of citizen science by indigenous communities in that kind of setting. It will also come into the others as well. But that's an important point, that especially when we talk about equity, that citizen science is not just something that's used in the developed world and by a small slice of the population. So we do plan to have an entire session on that. This gets to a question that came up in the chat about the the upcoming schedule. We don't have the full schedule on the website yet, but it will be going up shortly. I think that the link was posted in the chat. In any case, I would say check back. Certainly the next session is available, and I hope that this one tweaked people's interest enough that you will want to come back for those deeper looks into specific topics. Any of the panelists want to add something before we close up, because we are about out of time?
Just to say, George, that there was a question about the Pacific citizen science community and what they're up to. There is a video that was put together for UNEA 4. We can make the link available so that people can see that, and it goes through in detail what they're doing in the Pacific community with citizen science, because they're very proud of what they're doing.
That's great. That's great. Thank you. Anyone else? Final remarks?
just one of the emerging issues that we didn't get to today was First Amendment issues in the US and the Aarhus Convention in Europe, looking at the right to collect environmental data by citizens. So that's something I think we'll be focusing on in our Citizen Science Association Law and Policy Working Group and the European Union Citizen Science Association policy group as well. So stay tuned for that.
Yeah, and so this is Lee, and I'll just wrap up overall, and the point that Leah just made. The U.S. has at least had one circumstance where a state has passed a data trespass law, which has been overturned, at least in part, on constitutional free speech grounds. So there's another side of this that needs to be explored, and that's some of the barriers to citizen science. As George mentioned, we will next take up water and air in some depth, a little bit more specific exploration of the role of citizen science in those areas. I want to thank our speakers, thank all of the participants, and look forward to the next INEAS program coming up in about 2 weeks. Just watch for those programs on the INEAS website. Thank you and good day.
Thank you.
Thank you, and thanks to all the participants.
Thanks, everyone. Okay.
Great job, everyone.
Just sorry, Vital, that the line went down at my end.
No problem at all. I think we'll make the slides available for everyone on the website so people can review it. And I think we still managed to cover everything.
Yeah, I found myself talking to myself.
No, it's great. It's wonderful. Thanks so much.
I can't hear you now. Has everybody gone?
I'm heading out. Thanks, Martin.
Yeah.
Great talk.
Please feel free to hop off and we'll follow up soon and hope you all have a great weekend.
Yeah. Thanks again,
Thanks so
everybody.
much.
Bye then. Bye.
Bye-bye.